Hello students, and welcome to section 1-7, absolute value equations and inequalities. So let's take a look. As it turns out, we have already scratched the surface, if not done more than scratch the surface in most cases with regards to equations and certainly inequalities. With absolute value though, this is a new territory for us. So we're going to go ahead and combine some ideas. Some of which you know, but most of which you don't with absolute value for sure. So example 1, understand absolute value equations. What is the value of x in the equation 7 equals the absolute value of x plus 2? Now, as a kind of review piece here, the absolute value of any number is technically the distance that a number is from 0. So let's, for example, on a number line, just do a quick analysis of the absolute value of -2. And we're going to compare that to the absolute value of +2. And I'm going to do this on a number line. And to make my point, when I do this, we'll address this not just with these two numbers, but maybe also in a moment with any number using a variable x. So if I looked at a number line, plotted the point -2 and +2, but also 0, because that's really our benchmark for framing our distance. This distance is 2 units. This distance is 2 units. So as it turns out, the absolute value of -2 is equal to 2, because again, that's the distance that -2 is from 0. And the absolute value of +2 is also 2. Now, if I did this with, I'm going to make up an equation with the absolute value of x equals 2. Okay, so this is a separate example, but it's in a nice sense connecting the dots, so to speak, wherein if I asked you to solve something like this, okay, let me actually scoot this down. So if I asked you to solve something like this, for example, the absolute value of x equals 2. We know that the answer should be both positive and -2. We already said in the example above, right, that the absolute value of -2 but also +2 is equal to 2. So as it turns out, when you're doing a problem where there's a variable expression included with an absolute value, you're going to have to do some extra analysis. Now we can do example 1 officially with that background knowledge. So again, what is the value of x in 7 equals the absolute value of x plus 2? Our goal should be to get the absolute value expression by itself. And here's what they say. Solve for x by isolating the absolute value expression on one side of the equation. In other words, as you can see here, subtract 2 from both sides. When you subtract 2, and by the way, this is called the subtraction property of equality, what you'll see, and it's pretty nice how they subtract it. So 7 minus 2, of course, is 5. 5 equals the absolute value of x. So again, in my examples off to the right, our analysis hopefully is going to be pretty much the same in the sense where if you graph, there's one graph where -5 is to the left of 0 and the other 5 is to the right of 0. Both -5 and 5, that should read, are 5 units away from 0. So that's a typo. That should read 5. 5 units away, so the solutions are both -5 and 5. Again, as we saw in the example off to the right, the same applied basically to 2. When you did the absolute value of x equals 2, you get both 2 and -2. The distance is 2. Checking the solutions, you can go back and plug them in. So 7 equals what? Is the absolute value of -5 plus 2 going to be true? And the same holds hopefully for the other. Is the value 7 equal to the absolute value of 5 plus 2? Turns out that on this problem, if you test the theory, plugging in -5, you get yes. The absolute value of which is 5, so 5 plus 2 is 7. And if you plug in +5, you get the same result. The answer checks. And I do certainly want you guys to check your solutions really on all math problems, but on these specific types of questions, checking your answer is even more crucial, because there will possibly be moments down the road where maybe an answer doesn't work, even if you did the math correctly. So continuing on, so we can see here an equation, and in this question part, the absolute value of 2x minus 3 equals 1. Well, the process starting off, you've already got the absolute value by itself and the x in that case by itself. There's two possibilities though. When the quantity is positive, kind of like I referred to in the example up above here, you have a positive case, but you also have a negative case. So let's proceed. In the positive case, we literally rewrite the problem, getting rid of the absolute values. 2x minus 3 equals positive 1. And in the other case, 2x minus 3 equals negative 1. And then we solve each one. Okay, and solving each one, you can add 3 to both sides here, add 3 to both sides there. You'll end up with 2x equals 4 on one and 2x equals 2 on the other. Divide by 2. Okay. The expression inside the absolute value symbol can be positive or negative, so the expression can be, of course, positive and negative. So that's why we did it. I'm back to where I'm dividing by 2, so boom, x equals 2 and x equals 1. So the explanation there in the little word bubble here, this is a good one, so please pay attention to that. But again, I've already described this in my example from back here, case 1, case 2. The final solutions are in fact x equals 2 and x equals 1. I do recommend we plug it in. In other words, 2 times 2, 4, 4 minus 3, 1. The absolute value of 1 is 1. If you plug in 1, 2 times 1 is 2. 2 minus 3 is negative 1. The absolute value of negative 1, of course, is positive 1. So the two solutions check, and they're correct. Next, what is the value of this x in this expression? Now, right here, as you can see, the only x in the problem is inside the absolute value again, but it's kind of, if you can tell, multiplied, added, and you got another number there on the other side. So there's a whole litany of extra steps here. First step, to get x by itself, or the absolute value in x by itself, is to subtract 8. So if you subtract 8, the next step, you get this. So 3 times the absolute value of x plus 6 equals negative 3. Still got to worry or work with that 3 out in front. We're not going to worry about it because we're just going to divide it out. And if you divide it out, you get, as you can see, the math unfold from there as such, where you'll have this. You'll have the absolute value of x plus 6 equals negative 1. This is a problem though, and I want to explain. If you were to take the absolute value of any number, I don't care if it's positive or negative, even 0, the absolute value of any number can never be negative. So the fact that we see a negative number here after you get this all isolated by itself, this right here is a huge indicator that this problem does not even have a solution. And they should say that here. Yep, the absolute value of a number is a distance and cannot be negative. So the equation technically has no solution. Even if you were to split this problem into 2 different cases and you actually get numbers for solutions, if you plug those 2 numbers back into the original problem, they are not going to work. So again, no solution. Example 2. So it says in this little example, the cruising speed of Kennedy's boat is 25 miles per hour. She plans to cruise at this speed for the distances shown in the diagram. So for part A, what equation models the number of hours x that Kennedy will travel? Here is Kennedy, so she's traveling to the right. She is 80 miles from her destination, and we're going to go ahead and decipher when she is 10 miles left of the destination and also 10 miles right of the destination. In other words, when is she within 10 miles of her destination? Presently, she's 80 miles away. So let's see how this is going to play out here. The distance Kennedy actually travels is as such. So 25x minus 80, and we're writing it at an absolute value. and that equals 10. Here's why. So again, 25 is her speed in miles per hour. It's the distance she actually travels if we multiply it by x. Why? Well, if x is the number of hours and she's traveling 25 miles per hour, 25 miles per hour times the number of hours will in the end be her distance. If x is 1 hour, she's traveled 25 miles, and so on and so forth. Now, subtracting 80, now that's a necessary component because she is getting closer and closer and closer to the destination that is, again, 80 miles away, at least from the point that we're measuring it at. Because, again, we are approaching that point, this quantity needs to be subtracted from that quantity. Okay, so if she travels a total of, let's just say, 100 miles, well, 100 miles is going to obviously put her on the other side here. She'll be technically 20 miles beyond where she started. But again, the idea is if you subtract 80, and even if it's less than the distance she needs to go, subtracting is going to put her in a position either left or right as a total distance. Now you may be wondering, okay, well, what if this distance is technically a number less than 80? What if it's 60? Well, if this number is 60, for example, this obviously ends up being negative because 60 minus 80 is negative, but the whole thing, when you do the absolute value, ends up being positive. Okay, we still don't know what x is, of course. 10 on the other side here, it represents the number of miles that we are trying to calculate her difference. In other words, we want it to be deciphered 10 miles left of the destination, but also 10 miles right of the destination. So that number is necessary in our setup. Final distance from the 80-mile point, as I just described already to you, and that is the 80-mile value, but 25x minus 80. Now this problem continues on to the next page, so let's take a look. What are the minimum number and maximum number of hours Kennedy will travel? So let's take a look. I'm going to write and solve the equations for the two possibilities. If Kennedy travels plus 10 miles, the absolute value expression is positive. If Kennedy travels minus 10 miles, the absolute value expression is negative. In other words, 25 minus x equals positive 10. There's your case 1 like we described earlier. And 25x minus 80 equals negative 10 as we described earlier, the negative case. Solve each one individually, so add 80 on both, and on this, when you add 80 to both, 80 plus 10 of course is 90. Here you add 80 but it's negative, so it ends up being 70. And then if you divide by 25, you get x on one hand to be 3.6 and in the other to be 2.8. The solutions are x equals 3.6 and x equals 2.8. Kennedy will travel at least 2.8 hours and at most 3.6. Okay, so let's move on. Example 3. Understand absolute value inequalities. What are the solutions of an absolute value inequality? Solve and graph the two that you see. So this, as you see, the absolute value of x is less than 3. Basically what this entails, and I'm sure we can hopefully see that x less than 3 is equivalent to the compound inequality. At least in the graph we can see technically. In the graph you can see here you've got an open circle at -3, an open circle at +3. So as you can see back to this, x is certainly, as you can see, x less than 3 and x greater than -3. This right here, or better yet, this right here, -3 is less than x, which is less than 3, stems from the picture, and therefore the absolute value inequality takes shape thanks to this. As far as solving it, it's already pretty much done for you, but if you look at the graph again, the distances from 0 are 3, as well as you see here again 3. The same thing will apply to the part B problem. When the absolute value of x is greater than 3, this is not an and technically, it's an or statement. As they describe here, the picture again speaks for itself. X is less than -3 with an open circle to the left, or x is greater than +3. As far as the explanation, we are not looking at distances in this case, but we are using the absolute value to decipher that the compound inequality unfolds as an OR statement. This is a typical and this is the inequality that goes with that. Less than, well, OR with that.